Hello, my dear students in unit, and this is the first chapter of this data structure unit called Data Structure 1. And in this chapter, we are not only going to introduce about the data structures, its types, and the various importance of the data structures. Plus, we are going to discuss the linear list and various operations related to the list. All the topics which we have covered about the list in Python in class 11th are also applicable and are also available in your class 11 syllabus in 12 class 12 syllabus. So kindly revise those topics of class 11th also for your preparation of class 12 syllabus. Now I am going to start in this chapter with the introduction of data structure. Now data structure term is made up of the two words data and structure. Let us first understood the meaning of the data. Data are the raw facts and figures, and these data values are there, which are also called data items. Now data play a very active participant in the organization's operations and planning, and data must be aggregated and summarized in various useful ways to get the useful informations. And the computer is one such machine which does the data processing work in such a way that it gives you that informations in very easy way. Now before giving the informations, the data must be stored, organized, and processed and managed in the data systems effectively. So this is done through the data structures. It means in computers, data structures are an effective and reliable way to achieve these goals of the data. So means data, if you want to properly want to get the informations from the data, you have to store, represent, and organize and process and manage the data very in an efficient way, and the data structures helps us in doing this way. Now data structure term means there is first raw data, and the meaning of the data is there that it is a group of data of similar different data types stored in specific way and processed as a single unit. A data structure has a well-defined operations, behavior, and properties. Moving to the next topic, that data type and data structures. A data type is simply a set of values with along with some well-defined operations. For example, integer, float, string, these are your different data types and they have different behaviors. For example, an integer has behavior that no decimal point can be put in it, and a string has also behavior that the no two strings can be multiplied. Whereas the data structure is a physical implementation that clearly define a way of storing, accessing, manipulating the data stored in the data structures. The data stored in the data structure has a specific work pattern. For example, in a stack structure data structure type, there is a fixed pattern of insertion and deletion from one end only. Now Python also supports various data structures such as list, dictionary, tuple, etc. These structures have different operations and different behaviors. Let us now understand the different types of data structures which are available to us. Data structures are very important in our computer system. They not only allow the users to combine the various data types in a group, but also help us to processing, makes us the processing much simpler and easier. On the basis of the complexity, the data structures can be classified into two main categories. One is simple data structures and the other one is compound data structures. Simple data structures normally work from the primitive data types such as integers or characters, boolean, etc. So they have only the arrays, yeah, linear list comes in this category of type of data structures. But the complex data structures are more compounded with some other values. So we have the two main categories in the compound data structures. One is the linear and the non-linear. Here we have queue, linked list, which I am going to briefly discuss and introduce to you in a short while from now. Secondly is the non-linear data structures, tree, which are also commonly used. They are beyond the syllabus of this class 12, so we are not going to discuss more detail about the tree. So finally we can say that the compound data structures are of two types. One is linear and other one is non-linear. Okay, in the linear category we will going to learn stack, queue, and linked list, and in the non-linear category there is tree. We are going to discuss only stack and queue in the next chapter of this data structure, whereas link and tree are not in the syllabus. so they are beyond the syllabus of your class 12th. Here and now I am going to introduce you the various different types of data structures, such as let us discuss these different type of data structures in brief one by one here, and out of these some of them like linear list, stack, queue will be discussed in details in this chapter and in the coming chapter. Now if I talk about the arrays, arrays are basically a named collection, or it is a finite collection of the homogeneous elements. It means an array is a such that in which all the elements are of same type and they have a common name. For example, if I make a list in which all the elements are of same type, then it will be as an array. Arrays can be one dimensional, two dimensional, or multi-dimensional arrays. In Python, all are linear list or numpy arrays. So linear list is in your course, so we will going to discuss these arrays with the help of linear list in the current chapter. Numpy arrays are not in your syllabus, so the numpy array will be not considered in your syllabus right now. Now stack is also a linear data structure which is comes under the complex data structure category. It is a structure which follows LIFO method. LIFO means last in first out technique. For example, if you have seen a stack of plates, if shown as shown in this figure, if you are going in a party or in a somewhere invitation, invited to somewhere in a get together, you will see that there are the stack of plates. Now the plates are inserted and removed from that in such a way that they are inserted and such and removed from the top. If anyone is taking the plate, it will take from the top, and similarly if new plates are added, they were placed at the top of. So stack is one such type of data structure in which the insertion and deletions are done in such a way that the last element is the going to be removed first, LIFO order, or latest in also, and latest in is going to be first removed. Queue is, as the term queue, you know that it is a queue means a line. So queue is a FIFO data structure in which the first one is entering is going out the first. In this type of data structures, insertions are done from the one place called rear, and deletions are taking from the rear end, and the deletions takes place from the front end of the queues. It is much like the same line of people waiting for their turn to vote or to deposit bill, etc. The one person who has joined the first will going to be out first. Okay, so this is the way the data structures are handled in this way. Similarly, linear data structures are those data structures in which we are connecting the different data elements together through some pointers. There is these elements are called nodes, and the nodes will have the informations and the linking part. Informations will contain the data part, will store the informations, and the link part will contain the address of the link part. Such linked lists are created when we have large amount of data and placed at different places. A tree structure is also a data structure in which the elements are called nodes. The topmost node is called the root, and the bottommost nodes are called the leaves of the tree. In this type of data structure we are showing the branches, and in branches we are storing the informations. Such data structures are very complicated and not easier to understand, so they are beyond the syllabus of your right now book. Now questions comes in our mind: what are the types of data operations which we can perform on our data structures? For example, a list is also a data structure which can be managed. A array, if you say, which is a collection of the homogeneous elements, then it is called as a linear array, or it can be called as a linear list. In list or any other data type, the types of operations that we perform are as follows. This is the general criteria, or general giving you idea what are the operations that we can perform on the data structures. First is insertion. Insertion means always there is a process of adding the new elements into the data structure. Deletion means removing of the element from the data structure. The element is first searched and before its removal. Searching involves the searching involves the specified data element in the data structure. Traversing means the processing all the elements of a data structure one by one. Sorting is a process where we arrange the elements of the data structure either in a specific ascending or descending order. And merging is the combining the elements of two similar data structures to form a new data structure of same type is called merging. So these are the 5 and 6 operations which we perform on the data structures. We will try to perform these data structure operations on the list in this chapter, and some of these operations we will try to perform on the stack and queue in the next chapter. Rest all the data structures will not be treated here. So I hope you have understood all the operations which you can perform the data structure. Let us quickly once again revise all these operations. Insertion means how can you add a new element to data. For example, in a list, how can you add a new element? How can you add a new element in a stack? How can you add a new element in a queue? This is the insertion process. Similarly, deletion means how can you remove the elements from the array. Searching of the elements, yani how can you remove or search the element in an array or in any data structure. Then we have the traversal means how can you process the each and every element of the array. Sorting means how can you arrange the elements of an array list or any data structure either in ascending or descending order or any specific order. And the last is merging. It means that you are combining the two or more elements of the same data structure and giving the output as a third data structure of same type, that is known merging. For example, if you are joining the two lists and making a new another list is known as merging of the list. Similarly, if you are joining the two dictionaries and making a new dictionary, then it will be merging operation. If you are joining the two strings and making a now we will start with the first data structure, that is called length, or that is called the linear list. In this video now we are going to start the linear list. A linear list is basically the list structure whose elements form a sequence. In Python, the arrays are implemented through the list data types. Array is a homogeneous collection of the elements of same type. Homogeneous collection means elements are of same type and they have each element a common index. So we are going to discuss here about some particular things about the arrays of the Python using the list. Let us first start with the how can you find out the length or the size or the range of a linear array or a linear list. The formula for calculating the range of the elements in a list is ub minus lb minus plus 1. ub means upper bound, lb means lower bound. Okay, now try to understand these terms, upper bound and lower bound. In Python or in some other C languages, C, C++, if you have observed, if you are creating a list, you have heard about the Python, but in C, C++ there are the same thing is array. Now in Python lists or in C++ or C arrays, all are having a array like structure, and there is an index which is always starting from 0 onwards. It means in C, C++ or in Python, if you say in Python list, there is a 0 index, that is the starting index. All the elements will start from the 0 index and the so on. So how can you find out the length? You can easily find out the length in the arrays by the highest index plus 1, that is the highest index plus 1 will be the method. For example, if this is a list in which the index is lowest index will be 0 and the highest index is 8, so highest index is 8, the length will be 9. So here the formula is applied in this way, that ub, now ub is your 8 in this example, upper bound yani highest index, and lb is your lowest bound, that is 0. So length is calculated by putting these values in the formula of ub minus lb plus 1, that is 8 minus 0 plus 1 equal to 9. So the length is 9. In this way we can find out the length of any Python array or any array in C++. Or simply we can say the highest index plus 1 is the simple method of finding the length in these types of languages. However, in some other languages the array index not always start with 0. This index can start with some other number also. For example, there can be an array in which the index can start with the 5. Okay, so in that case the and ending at the index 13. How can we then find out the length of the list? Then in that case we upper bound will be 13 because highest index is 13. Lower bound will be 5 because lowest index is 5, not 0 here. So the formula will be L is equal to UB minus LB plus 1, that is equal to 9. So in this case the length is still 9 but the index is starting from 5 to 13. This index can be negative also in some cases. For example, consider an array in which lower bound is minus 9 and the upper is 2. So the length will be calculated as 2 minus 9 plus 1, that is 2 plus 9 plus 1 equal to 12. So in this case the length will be 12. You can count 1 2 3 4 5 6 7 8 9 10 11 12. So this formula is a general formula which can be applied on all the types of arrays in all the languages. So this formula is applicable for finding the length of a linear data array in Python. Now next what we can do is that in a linear data structure we have already covered in list about various things about the list in the class 11 syllabus. In this chapter we will still do some revisions, and first starting with the operation searching. Now the searching as a means finding an element in a list or not. This program we have already done in the class 11th where we have find a particular element in there are two different algorithms. Algorithm means two different methods of searching an element in a list. One is called linear search or a simple search, which is the searching an element scanning the entire list, traversing from the entire list. And the second one is the binary search, which we are going to discuss after a short while from here. Let us first start with the linear search. In a linear search, you know that the elements are in a particular one sequence and we try to search element from the 0 index and moving to the last index. A linear search example is also linear sequential search. Let me show you the program of a linear search. See on your screen there is a program to search an integer in a list. For example, there is a list given to me. Length of the list I have found in the variable length. Now enter the element to be searched. This is passed this list, length of the list, and the element to be searched is passed to a function lsearch, which is the linear or sequential search. Now what this function is doing is that it will start from the index 0 to the last index. Length will give you the last index because in range we always go one less than the highest value. Length is -1 will be the highest index up to which there will be we have the value of I. So I will be initially 0, then it will be 1 2 3, and the highest value of I will be length -1. Now one by one what will happen? Li means L0 is compared with the element to be searched. If the element is found, it will going to return the element. If the element is not found, it will return -9. Now first this loop will try to search element, and if the element is found, it will return that element. Otherwise, finally when the entire array is a list is scanned and the element is not found, it will return -1. So here I am going to check if I is not equal to minus 999, means the element is found and this is the index of that element which is returned by this. If the element is not existing, then the value of I will be equal to minus 999 and the message will be generated that number does not exist. This program is already explained, used twice or thrice in the class 11, so nothing is there to be much in explaining in this program. Plus not no need to run this program here. The students can learn this algorithm and keep it in mind to find out the linear search. For example, linear search in an array means, see here, enter the elements for the list. You are entering the elements and then you are passing the array and the number of elements. Enter the elements to be searched for, you are passing that. Now we are going to explain you the binary search method. Binary search method is a very special and efficient method of searching the item in a list or in a combination. In a binary search we use the telephone method or telephone directory method, in which all the elements are arranged already either in ascending or descending order. It means for a binary search the first preliminary condition is that all the elements must be arranged either in ascending or descending order. Let us try to understand the binary search method. Let us suppose I have a list with elements, some elements. These elements are arranged in ascending order in a list. Now you can see that L0 is your 10. Want to search an element in the array existing or not? X is equal to 20 exists. Okay, so you will find out. How you will find out? That you will first come to the first method, is that you will find exist or not. 21, if you say yes, it is existing in index 3. 30 is no, it is not there. How can you find out that there are two methods? One is linear search, but the drawback of linear search is that it is not good for the large arrays having large number of elements, as its search time is linear function of the number of elements. Linear search is not a very good method of searching, because if the array is very large, then it is not efficient, because the number of times is linear function of the number of elements. More the number of elements, more the time will be taken. Now binary search is that this must be sorted either in ascending or descending order, and the size of the array must also be known. Now here I am giving you the program of binary search also. Let us try to understand this program. This is suppose an array and you want to search an element. You will try to find out the element in the array or not. Using this, you will pass the array and the element to be searched into the array, this function. Now start is equal to 0, length last will be length of the highest. There will be two variables, one is at the starting location and other one is at the last location. Let me show you how you can have. For example, you want to check whether the 21 is existing or not. So you will do what? You will take a variable start at the starting location and the last will be at the end location. So your start will be here 0, start will be 0, and last will be the highest index, that is the -1, that will be the length -1. Highest index will be the length of the array -1, yani length, we will find out the length of the array -1, that will be the value of the last. Now there will be a loop starting only when the start is less than last. Here start is 0 and last is 11, so start is less than equal to last, condition is true. We will find out the mid of that. Mid of the that means 0 plus 53 0 plus 11 divide by 2, yani 5.5 divide by 2 gives you 5. Okay, we will find out the mid element. Okay, Now when we try to find out the mid element, there are the three cases. Okay, now the mid element is 28 here. Let me repeat it again. You will first take the start is equal to 0, and the last will be the index of the highest element, that is the here highest element index is 11, so last will be 11. Now you will find out the mid position. Mid will be 0 plus 11, that is 11 divided by 2, 5.5, but 5.5 cannot be, so converting it into integer we will get 5. So mid will be your 5, that is a the element to be searched and the mid element. That there can be three cases. Compare this 21 with the 28. There can be three cases. Either the two elements are equal, yani x is equal to list mid, or x can be greater than the mid element, or it can be less than. Okay, these are the three situations. What happened that this element can be either equal to this, or it may happen that this is the element which you want to search and this element should be equal to this, or it can be greater than or less than. Okay, the element to be searched is greater than or less than. Let us compare what we will do in the either of the cases. If it is matched, okay, if x is equal to 21, here answer is no, but if we search the number we would have stopped here and returned the as a mid as a position of the. If this match, this would have matched, we have returned the 28 and the index of the element, but here 21 is greater than 28, no, the answer is no, so we move to the third case here. See here, first case is not matching. If it would have matched, then we have simply said that the item is matched and the element is okay. Now the third case is 21 is less than 28, yes. So in this case what will we take? The first half. Why we will take the first half? Because we know that this element is less than 28, so obviously the element chances of getting the element will be in this half only, not in this half, because 21 is not in this range, but 21 is in the range 10 to 28. Okay, I hope you have got it. Now you will change your criteria of searching between these two elements. Your list last now should be at 23 and you have to search element between 10 and 23. Okay, so what you will do, that you will change your last equal to mid minus 1. Okay, and start will remain as it is. Again find out the mid value, and in this case time mid value will be 2. Mid value will be 2. So this second half we have rejected. Now this will be start, this is last. Again the mid element will be this one, 14. Now what will happen? Is 21 equal to 14? The answer may be no, so we move to the case 2. Is list is greater than, if x is greater than 21, is greater than 14, the answer is yes, so we will move to the second half. Now in this case we will reject this part and we will select only this part. So we will select only the 21 and 23. Again we will conduct a mid element will be your mid, in this case will be 3 plus 4, 7. 7 divided by 2 means 3. So your mid will be again 3. Is 21 is equal to 21? Yes. So you have searched the elements, you will stop the search and you will return the index of this element. See the code here. If every time in the loop it will going to calculate the mid value, check the element at the mid value is equal to the value, then return the mid value, else you can find the greater value. Okay, finally your either you will search to an element, either you will reach to an element, or your if the element is not existing you will going to return 999.